and I will presenting to you the Horizon 2020 project of IDRUSA, which I coordinate. Can you please confirm that you can hear me well and that my slide presentation is good?
Yes, Simon, perfect.
Oh, okay, good. So it's very interesting to talk, to hear about all this nice work that started at a very basic level of a few liters of reactor, and it's now being upscaled more. And I will present you IDRUSA in a, let's say it's a project that is of a bigger scale. It's an innovation action project. So we're talking about a scale of some cubic meter per day. But before this, I would like to just introduce a little bit our group. We are in the sanitary engineering group of the National Technical University of Athens in Greece. We are an engineering school and we belong at the civil engineering department. Our group is dealing with water resource management. We deal with water, wastewater, resource recovery, water reuse. And we're glad that over the last couple of years, our group has grown significantly. We are around 30 people in the group, including around 50% of PhD students. So these are some of the people that I was able to pull together, and this is me here, our director Danos, and we have a good number of gender balance also, as you can see. We are quite active in terms of research projects. We are involved and have been involved in a number of Horizon 2020 projects and national projects. Apart from IDRUSA, we are also working on the Axel Water, the highways, SPY project, Horizon projects, and the recently concluded Smart Plant project. So I will now go into the actual presentation that is the IDRUSA project, and I have a video to share with you. It's a 3.5-minute video of the project.
Imagine a future summer day on an island. One of the hottest summers this island has ever seen. But wait, there is an oasis ahead. How is this possible? Let's see where it all started back in 2018 with IDRUSA, an innovation action project funded by the European Union with the ambition to create regenerative and nature-based water solutions. We are a constellation of international partners consisting of universities, research institutions, companies, NGOs, water utilities and municipalities, and we are on a mission. Let's think for a moment. The Mediterranean region faces significant challenges: dry zones, places with high touristic activity during the summer, problematic farming practices, wasted water resources. In IDRUSA, we revolutionize the water value chain by closing the loops, and the revolution is circular. We use a combination of techniques, both traditional like local crops and natural irrigation systems, and modern like ICT technology and online monitoring, mixed with biomimicry technologies, nature-inspired innovations. The journey of IDRUSA has already started in 3 Mediterranean islands. Let's take a look at how they work. On the island of Lesbos, we develop a rich agroforestry ecosystem. We treat domestic sewage by anaerobic processes coupled with constructed wetlands to produce biogas, which is upgraded to methane and used to fuel a car, sludge to be processed through an innovative compost cultivator, and treated water, free from pathogens, that will directly be used to fertigate and irrigate a 10,000 square meter field, including forestry trees, orchards, bushes and herbs. On Mykonos Island, we install an innovative rainwater harvesting system on a remote dry hill to irrigate oregano and produce essential oils from it. Meanwhile, on the same island, we collect rainwater from the house's rooftops to provide water for domestic use such as toilet flushing, and to recharge groundwater sources for the irrigation of a lavender field. Moving now to Tinos Island, we apply an innovative and nature-based desalination system that mimics the mangrove plants to produce edible salt and to irrigate a tropical fruit greenhouse. On a different site of the island, we upgrade an existing ecotourism facility with a combination of applications. The system aims to create self-sufficiency in terms of water, energy, and food production. All our systems are circular, creating holistic regenerative solutions that can be customized and integrated to local needs. This is our journey for now, but 26 more islands and coastal areas are about to follow, from France and Egypt to Mexico and Australia. We are a community of water allies. We are closing water circles and we come with solutions. Join the circle.
Okay, so this was it. And regretfully, this was the most interesting part of the presentation. And now it will be my presentation, the least interesting part. Our project is, as I mentioned, Innovation Action Project. We have 6 demonstration sites, all in 3 Greek islands, as the video mentioned. And we are well within the 3rd year now of the project. We are a bigger group, so each meeting is like a small conference. Here you can see on the left, it's from the meeting we had in Nice, and on the right in Barcelona. Of course, both of these meetings were before the COVID era. So now we regretfully have had the last 2 meetings over telemeetings. We are a variety of 28 partners, and if I were to show you the project in one picture, this is it. So this summarizes, in a sense, the Idrousa water loops. We tackle Mediterranean water scarcity issues by integrating other engineered approaches together with nature-based and nature-inspired solutions. So we have wastewater cycles with anaerobic processes together with constructed wetlands. We deal with the rainwater harvesting issues and the seawater in order to have a low-cost treatment solution. And all our systems are try to be circular, meaning that there is a strong interconnection with agricultural activities, but also non-domestic, domestic non-potable water use. So just to describe a bit more what we are doing in each demonstration case, because it was only briefly mentioned by the video, in Lesbos Island. Lesbos is an island located in the very east of Greece. It's very close to the Turkish borders. And there we have the upflow anaerobic sludge blanket coupled with a 2-stage vertical flow constructed wetland, plus a filtration and disinfection unit. And this treatment train produces water, reclaimed water that is rich in nutrients, but doesn't have the pollutants of the organic carbon in the solids. So we are able to achieve the limits of unrestricted irrigation. This is the scheme you can see with the anaerobic processes, the saturated and unsaturated constructed wetlands, together with the membrane filtration and disinfection. We aim to achieve the limits that are required by the Greek national law by actually bypassing the ultrafiltration unit so that we can reduce the cost. We also have a sludge treatment wetland for the anaerobic biomass that is produced coupled with a composting unit. The system has versatility in order also to boost its exploitation potential and also a good business case, since with the agroforestry is a combination of trees together with crops and shrubs that provides an increased benefit for the farmers. Here you can see some pictures. The site has been running now for a couple of months, and you can see here it's a two parallel anaerobic reactors, total volume of 40 cubic meters, with together on the back with the gas holder tank, and on the bottom you see the constructed wetlands, which are actually biodiverse. We have 6 different species of biodiverse constructed wetlands, and together with those we are also testing the bioelectrified constructed wetlands, which are much more compact and can also produce some electricity. Biogas is upgraded to methane using a chemical scrubbing process and the recovery of the chemical to be reused again. The idea is to compress and remove the carbon dioxide and produce pure methane that can then be compressed and be used as a fuel. These are a couple of pictures of the post-treatment units. They consist of membranes and ultraviolet radiation for disinfection. But as I mentioned before, through optimized operation, we aim to achieve the water reuse limits even without the UF system. The demonstration site 2 is actually adjacent to demonstration site 1, since it uses the reclaimed water that is produced from the wastewater treatment facility to irrigate. It consists of 1 hectare of land that where we have developed a variety of species, including trees, bushes, and crops. This is actually, you can see here this field. It used to be a barren land, and it's now being actually cultivated with a variety of crops. The demonstrator 3 is a remote rainwater harvesting system that can be used for agricultural irrigation. So imagine a place where there is no roof, no house, to valorize rainwater. So what has been done, the consortium has developed a subsurface rainwater collection system, and this is, you can see here, the field is a 4,000 square meter of oregano, and this on the top left is the water storage system, and on the bottom is this is the storage, and on the bottom is the collection system. We've actually produced a 3D model, real model of the system that you can see here with the collection system and the storage system and the cultivation. Again, here you can see some pictures of the model, of this model, and it produces the final aim is to produce through this circular use of water essential oil that have a high market value to be valorized locally. These are some pictures of the construction system. These are the tanks here. This is the irrigation system. It's been running for more than a year now, and we have been able to reach our KPI, key performance indicators, in terms of water collected and quality, which is currently under assessment. What I want to mention is that in all of the DRUSA systems, we try to harmonize as much as possible with the natural landscape. So you see that all the geomembranes for the tank is covered by stone, which is traditional to the place where it has been installed in Mykonos Island. Again, here you see this is a reconstruction of the lodge, where we aim to put a system for the extraction of the essential oils and to be used as a demonstration system. We also have a low-cost monitoring system in place for the meteorological data, for the water quality data, and even for the flow meters. And all of this is autonomously powered. We're talking about a decentralized scheme. So it is powered by photovoltaic systems. The demonstrator number 4, Hydro 4, is a domestic rainwater harvesting and aquifer storage system. So we have roofs here to collect rainwater, but we not only collect rainwater, but we also collect stormwater and urban runoff. So we have the nature-based approach of the bioswales, where we collect stormwater. So we have basically 3 systems integrating in a domestic residence. In Mykonos Island, we have a residential rainwater harvesting system. We have a slow sand filtration process for rainwater treatment. And this coupled to the disinfection process, we want to see if we are able to get the water standards up to drinking water quality, which is quite difficult, I would say. And then we also have the bioswale system. Here, what we do is we use for the storage of the water, rainwater, stormwater, surface runoff, we use a combination of tanks, but also we have aquifer storage. So we store the water into the aquifer during the rain season and use it during the dry season. These are some pictures of the construction. So we have the development of the roofs with ceiling material, the construction of the wells, the construction on the bottom left of the bioswale to collect the rainwater. This is a very good, a nice way and a friendly way to actually avoid rural flooding issues, because these existed in the field. So we avoid these issues with the bioswale. And this is the cultivation of lavender. Actually, the lavender is here, but it's very, very small at the moment, so you can't really see it. So moving on to the Tinos Island demonstration sites, there we have the Hydro 5 is basically low-cost seawater desalination by solar practices. So we have the seawater is put into these solar panels, where due to the high temperature, it evaporates and then condensates. It is an innovation by our partner Planet, and is able to treat both desalinate both seawater and brine, and produce water and also edible salt. And we feed the water at the moment. This here is the seawater that is fed into the mangrove still systems. Mangrove, because of the plant mangrove that is able to resist the salt. It's a nature-inspired approach. And then into the production greenhouse, where we cultivate tropical fruits. You can see here the actual system implementation, which is running a few months now. And also part of the greenhouse is also ready with different types of tropical fruits. We had the honor that the system there was actually visited by CNBC biomimicry documentary. So they flew from the US to Tinos Island, and they made a 7 to 8 minute film of the technology. Plus, the technology has also received a grant for application in Oman. The last technology is basically developing very small water loops in an ecotourist facility in Tinos Island. So there we have different kinds of water, rainwater, sewage, even vapor water loops, where everything is valorized. The Tinos Ecology is a touristic facility that is off-grid, meaning that it covers all of its energy requirements through photovoltaic panels. And also the reserves of water are low. So they want to valorize all types of non-conventional water sources. So we're talking about rainwater that is used for toilet flushing. We have wastewater or gray water that is treated by the reed bed and then is disinfected to be used again for some cultivations, and even vapor water that is used for more high added value applications. Even we're testing it for drinking water applications. These are some photos of the ecotourist lodge. You can see here the development of the wetlands. This is the system of the photovoltaics. They have a photovoltaic system for the collection, but also they have batteries to store the power in order to use it during the night. They have a very, very successful business case and circular approach because they are able to produce a variety of crops, and they actually use these crops for their residents. They have around 10, 12 residents during the summer season. This is the capacity, and they actually they are fed by the Ecolodge products, and they also have a business case. They support local food and beverage facilities, mainly restaurants. And here is also a US application of the vapor condensation system using also it is powered by solar energy. We have extensive monitoring system for all the hydros. It is not easy to work in these systems because they are very remote. The closest application, that is the Lesbos case, where there is a lab to do analysis, is 1.5 hour drive. And some of them in the whole vicinity of the island, there is no facility. So we rely a lot on the online monitoring activities to support our case study. And of course, we couple this with lab analysis in order to confirm, but also to do some more analysis that is required for example, inorganic or organic micropollutants. We'll be developing a nexus model within Idrousa based on all the data that are currently fed to our system. Another thing that I think is important and is worthy to highlight that is made by the Brunel University team is that within the project, we have developed a multi-sectoral water circularity assessment tool that considers the water, energy, food, and industry, in this case, agriculture nexus. And this tool has found a very big impact within the water industry. It is currently being used by very big companies like water companies like Jacobs in the tendering procedure to apply for water tenders. What Idrousa wants to demonstrate is that there is business case in the small water systems, and small water systems are often criticized about being cost inefficient, and it is true. If you compare a small system, either water treatment or wastewater treatment, with a large, there is no economy of scale in the small systems. But in Idrousa, what we want to see, we want to demonstrate is that through the cascading effect of integrating the water cycle with the end products, and when I mean the end products, I mean the agricultural products, the salt, energy, then you can have a real, a lower payback period, and this can make a business case. And the aim is to valorize resources for the local stakeholders, meaning the local water utilities, municipalities, tourist businesses, farmers. Although the pilot systems are all located in Greece, because the idea is to develop a circular island, we have 25, more than 25, I would say, replication and transferability case studies all over the world. And also we have some very real interest from a couple of sites that are interested to develop Idrousa solutions in their case. Some ideas and some numbers about the Idrousa dissemination and communication activities. we have been impacted by COVID, so we had more events before the COVID effect, but still we're quite active. We are approaching 300 dissemination activities in the 32, 33 months of project operation. It's a very good number, I think, and we have several thousand followers in the social media. We have LinkedIn, Twitter, and a Facebook account. A strong element of Idrousa is the co-creation part. So during the early stages of the project, we did some co-creation workshops in the 3 islands, and we actually tried to involve the local population in shaping our solutions. And I'll give a couple of examples. In the first 8 months of the project, we did an ethnobotanical study of the different species we could cultivate in the agroforestry system. And more than 60% of the actual species that were planted in the agroforestry system are actually through suggestion of the local population. They know very well the local microclimate. All the generations have the wisdom to support what can be planted and what not. Other things we also asked people is about what they would think is important to monitor in their water, in the rainwater, for example. And 2 of the things that were recurrent in the 3 islands were the salinity. The groundwater suffers from salinity issues from seawater intrusion, and the other was microbial contamination. We have had also job opportunities for the locals through Idrousa project, and even synergies for local co-production activities and dissemination activities. Some of the dissemination highlights, as I mentioned, the CNBC documentary. We have been in the Greek national TV, a couple of events in Spain, including the IP Water Conference in Zaragoza, and also the application of the press release of Idrousa in the open access government. Idrousa is a member of the ICT for Water Cluster project of the EASME of the EU, so it capitalizes a lot through visibility through this cluster. Again, here you see some local dissemination in the national TV of Greece, and also the transferability of Idrousa case study in a press release in the European Chemistry Association. I forgot to mention that we also have a strong Spanish participation involvement in the project. We have the spin-off IRIS from the Autonomous University of Barcelona, who have actually designed and developed the anaerobic reactors. We have ICRA that are doing the monitoring of organic micropollutants. And we also have the Catalan Water Partnership that has supported a lot in the dissemination of our project activities. A bottleneck of many projects is that the fact that once these projects are finished, the funding is finished, there is the project and the technologies die with the project ending. So we don't want this to happen with our project. We have worked on the exploitation, marketing, and next page of our technologies from the very beginning. We already have solutions which are in the market and are selling. So for example, the low-cost monitoring tool with Idrousa is in the market. And we also have, I think, 5 projects, national and European ones, where we are implementing Idrousa solutions at different environments. And I would like to make a reference to 2 of those. It's the Axel Water, European Spire Horizon 2020, where we are transferring some of our solutions at an industry level. So Idrousa is not about industry, but now we're transferring our technologies within an industrial content of a brewery, the largest brewery in Greece, and a dairy industry. And we also have a national project where we are implementing urban farming activities and the rainwater solutions of Idrousa in order to have these kind of activities in a municipality. As I mentioned, we are active on the Facebook, LinkedIn, and Twitter. We are also following now a Conserval project. And if you want more information, this is also the web.